Let's talk about how to find an inverse of a function. We're going to do so algebraically this time. So our first step is to replace f of x with y. After you replace f of x with y, you're going to switch. You also may hear this called interchange. X and y. You're going to solve your new equation for y and replace y with our inverse notation, f inverse of x. If you do not do this last part, you're not completing the problem. And if you need to verify if two functions are inverses, you need to find both f of g of x, so fog, and g composed with f of x, golf. And if they both equal to x, then they are inverses. So you do the composition both ways, and if you get x each time, they're inverses. Okay, we're going to do some composition to prove that they are inverses. I'm going to let f of x be my purple function. I'm going to have g of x be my orange function. And I'm color coding because we're going to be doing some composition. So we need to first find f composed with g of x. But remember that when we do this composition, it means we're plugging g into f. So this really means that we need f of our orange function. Okay. So our f function is 3 all over, I'm going to put in some parentheses, minus 4. And this is where x was. Instead of x minus 4, we're going to plug in the 3 over x plus 4. Because we do not have anything in front of the parentheses that we need to distribute, our next line, we're just going to drop the parentheses. So now what we have is 3 all over 3 over x plus 4 minus 4. We're going to do some order of operations. The plus 4 minus 4 can go away. That gets us 0. So now we have 3 all over 3 over x. Remember, whenever we divide by a fraction, and that's what we're doing right now, we have 3 divided by 3 over x, we get to multiply by the reciprocal of the second fraction, which is a fancy way of saying times the flip of the second fraction. And remember that any fraction, or any whole number, I should say, can be rewritten as a fraction over 1. So when we try to do the multiplication here, 3x all over 3 means the x's or 3's cancel. We're left with x, which means the composition of f composed with g of x equals x. So the first way is good. We need to check the second composition, so the other direction. We need to find g composed with f of x. And that means we're going to plug f into g. So I'm going to write g out. We have 3 over parentheses. Let's try writing it again. Wait. 3 over x So I'm going to put a giant parenthesis. And then we have plus 4. But instead of having x in the bottom, we're going to plug in our f function, which is 3 over x minus 4. Now we can't cancel the 4's right now because the one on the right in orange is big. The one in purple is small and stuck inside a denominator. But what we can do is to rewrite our fraction because we have 3 divided by 3 over x minus 4, and then my plus 4 comes down, which means when we divide by the fraction, we're going to be multiplying by the reciprocal, which means that x minus 4 over 3 shows up. Our 3's cancel because there's one up top and one down below. X minus 4 plus 4, but this time the 4's go away and we get x, which means that g composed with f of x is also x. And if both directions hold true, g and f are inverses. Okay, so remember, an inverse undoes the mess that the original function put us in. Let's actually find some of our inverses algebraically. So we're given f of x is equal to 5x plus 13. This is a linear function, the y equals mx plus b. It's a polynomial, which means that we already know the domain of this guy, but that's all right. Let's go ahead and work this out and then we'll talk about it. So to find the inverse, first step, replace y for f of x, or sorry, replace f of x with y. Step 2 says we need to flip the x and the y. So now we have x is equal to 5y plus 13. Step 3 says that we need to solve this equation for y. So I'm going to rewrite my equation with y on the left-hand side because that is the variable we are solving for. My first step will be to subtract the 13. So I have 5y equal to x minus 13. And then I'm going to divide both sides by 5. You have 2 ways that you can write this. You can leave it as x minus 13 all over 5. Or you could do x over 5 minus 13 over 5. Either one is fine. But in the 4th step, you need to make sure that you replace y with the inverse notation. So you either need to have f inverse is equal to x minus 13 over 5, or f inverse is equal to 1/5 x, or x over 5. These guys are the exact same, minus 13/5. Either one is fine, but remember to have your f inverse notation. When you're doing the domain and range of the functions, you may find it easier to keep your notes organized if we do a little chart. So we're going to have domain and range. as some of our rows. And then I'm going to have f of x and then f inverse of x. So domain of f of x is a linear polynomial. We like polynomials because we know their domains are negative infinity and positive infinity. And if we found the domain of f of x, that means that we found the range of the inverse. Because remember, we flip the x and y's for our inverses. Now our inverse, even though it looks kind of icky, it does not have any radicals. It does not have any exponents other than the one. Doesn't have any variables in the denominator. This guy is another polynomial. Just looks a little different, but that's okay. And because he's a polynomial, we know the domain is negative infinity to positive infinity, which means that the range of the original is also negative infinity to positive infinity. Let's look at number 3. We have f of x is equal to x minus 1 in parentheses to the 5th power minus 4. Okay. All right, so we got this guy. First step, replace f of x with y. So y is equal to x minus 1 to the 5th minus 4. That's step 1. Step 2 says flip x and y. So instead of y equals, we're going to have x equals, and then we have y minus 1 to the 5th minus 4. Step 3 says that we need to solve for y. I'm going to rewrite this with y on the left-hand side because that's what we're solving for. And I'm going to put my x on the other. I left y in orange, that way we remember what we're solving. Start by moving the 4 to both sides, or to the other side. We have y minus 1 to the 5th is equal to x plus 4. Okay. We need to get rid of the exponent of 5. We're not going to try to distribute the 5 as an exponent because this would not be y to the 5th minus 1. If we actually tried to do the algebra on this, you would take y minus 1 times itself 5 times, and you will get into an even bigger mess than if we just did our next step. Okay. If you think back to the square root property, when we had x squared, we took the square root of both sides. Here we have something to the 5th power. Because we have it to the 5th power, we're going to take the 5th root of both sides. So we're going to take the 5th root of y minus 1 to the 5th. And whatever we do to one side, we have to do to the other side. This time we do not need a plus or minus because our index, the little number on the radical, is odd. On the left-hand side, the 5th root and the 5 take care of each other. We don't need the parentheses anymore, so we have y minus 1 is equal to the 5th root of x plus 4. We need to add the 1 to both sides. And we get y is equal to, you can either write the 5th root of x plus 4 plus 1, or if you're worried about your 1 getting under the radical, when it doesn't need to be, you can do 1 plus the 5th root of x plus 4. Either way is acceptable, but do not forget the very last step is with your notation. So our fourth step, we need to do the inverse notation. So f inverse of x. Try that again. F inverse of x is equal to the fifth root of x plus 4 plus 1. So this time we have a radical equation for our inverse. It is not a polynomial, but that's okay. We can still find the inverse. Okay, so domain range of each function. Let's go ahead and do our chart. We're going to have domain range on our side. Oops. Try that again. My lines are all over the place today. We have our original function. We have the inverse. Okay, so our original function was a polynomial. And we know the domain of a polynomial is negative infinity and positive infinity. And if we found the domain of the original, we found the range of the inverse. Our inverse function is a radical function. Remember, radicals with the domains fall into two categories, index even, or the index is odd. If your index is odd, your domain is immediately negative infinity, positive infinity. And because our index here is 5, which is odd, our domain is negative infinity, positive infinity, which means that the range of the original function is also negative infinity, positive infinity.